Assalamualaikum warahmatullahi wabarakatuh. Greetings everyone. My name is Muhammad Najibuddin bin Abdullah. Today I will present to you about my bachelor's degree project, which is development of food waste filter by using eco-friendly material with sensor. For the introduction, food waste filters are apparatus used to filter out the residue resulting from food and cooking. Various types of form of filter used in home kitchen that are easily available in home appliance stores or online purchases. Basically, this filter is used for large waste from getting stuck in sink pipe to the outlet to the drain. In this study, the use of substances to filter food waste should be determined to assist in achieving the objective of the study. Therefore, the environmental and eco-friendly material such as rice straw, coconut husk, and activated carbon are used in this food waste filter. By using these natural substances, it will be low-cost product of food waste filter. It also can make the waste water that flow out to the drain has less content of pollutant. Furthermore, infrared sensor, which is IR sensor installation on the filters, is also applied in the study to assist in maintenance work and cleaning of waste filter. So, the objective for this project is to observe the efficiency of food waste filter incorporated with IR sensor. Next is to evaluate physical, chemical, and biological properties of wastewater before and after apply the food waste filter. And then to measure the time taken needed for the food waste filter to be filled with waste until detected by the RI sensor. For the literature review, greywater sources, which is kitchen sinks, alkaline chemical pollutants like cleaning chemicals and detergent are found in kitchen greywater. Dishwashing detergents, oil and fats, food residue, hot water, raw meat washing, fruit and vegetable peels, drink or coffee, residue of food preservative, and sand and clay particles are all considered to be kitchen greywater. Additionally, kitchen greywater has the greatest concentration of suspended particle, turbidity, organic compounds, and nitrogen. Table 1 shows the characteristic of greywater from different sources. And then table 2 shows the water treatment technology that have been developed from the previous study. For example, is disinfection by Wang 2020. It is liquid chlorine ultraviolet light to treat the wastewater. And then activated carbon filter, which is oxygen added to activated carbon, allowing millions of microscopic holes between the carbon atoms to open. As a result, very porous surfaces with areas ranging from 300 to 2000 square meter per gram are produced. And then sand filter, which is a very famous use in water filter, which is sands, coarse bark or mulch beds that trap and absorb impurities when greywater run through. Okay, for the methodology, we start with designing food waste filter until data analysis, which consists 3 objectives that have to be completed. From designing food waste filter, material collection, product manufacturing, and then product testing for objective 1. And then for objective 2, water sampling for pre and post filtration to determine the greywater characteristic, which is physical properties, chemical properties, and biological properties, which has 5 parameters: pH, turbidity, COD, total suspended solid, and then BOD. And then for objective 3, data collection of greywater characteristic and food waste collection, and then data analysis, result and discussion, and lastly is conclusion and recommendation. Okay, the material used are coconut husk, activated carbon, and rice straw arranged in the filter. In addition, the filter itself is a mini drawer having 5 levels. All material will be filled into the drawer half of the size. Grab sample method are used in this water sampling based on APHA 2012. Water characteristics are determined by conducting the parameter testing, which is COD, BOD, turbidity, pH, and suspended solid. Table 3 shows the wastewater characteristic, method, and equipment. Okay, this is all 5 parameters that will be conducted in this study, and then this is the equipment used, and then the method for this parameter. Percentage removal for the parameter are recorded based on pre and post filtration. The duration of time needed for the filter to be filled with effluent until detected by IR sensor are taken in the study to observe the effectiveness for the food waste filter in filtering the grey water. Okay, next for result and discussion. Figure 2 shows the product development of food waste filter. This is food waste filter that have been installed under the sink and incorporate with sensor system, which is IR sensor. The suitable of the filter under the kitchen sink is emphasized to allow the wastewater to flow properly to the drain. The connector pipe is used to connect the filter with sink and outlet drain pipe. Standard pipe used for kitchen sink is 40 mm diameter PVC pipe. Hence, 40 mm connector pipe is used to connect the sink to filter. This food waste filter is originally a multi-purpose stage mini drawer that has been modified into a food waste filter. Furthermore, 5 mm times 5 mm of filter net was used between each drawer and filter media except for the first stage drawer and the last drawer. The additional material used to help the water flow smoothly in filter wool is filter wool that has been placed in the last drawer. Next, the sensor system. A buzzer and battery are attached behind the filter while the IR sensor is connected to the filter. The distance between detector and the reflections object for this IR sensor is approximately 2 cm. Table 3 shows the data collection of kitchen wastewater properties. This is the value of 5 parameters that include in this project for pre-filtration, and then this is for post-filtration. And then this column shows the percentage removal of 5 parameters after have been filtered. Based on the table above, the turbidity value for pre-filtration is 298 NTU, and for post-filtration is 137 NTU. Meanwhile, the pH value of pre-filtration is 5 and post-filtration is pH 8. The percentage removal of these two parameters is counted using the formula mentioned in the previous chapter. For turbidity, the percentage removal is 54%. Meanwhile, for pH value, there is addition of value from 5 to 6 from 5 to 8 or acid to alkaline. It is occur due to different in time use of water sampling. Furthermore, the type of washing and waste produced in kitchen are vary. Therefore, the wastewater may be acidic or may be alkaline depending on current use. Based on sewage discharge standard B, the acceptable value of pH value is 5.5 to 9.0, while standard for turbidity is not stated. The parameter involved in determining the chemical properties of kitchen wastewater are COD and total suspended solid. The COD value of pre-filtration is 788 mg per liter, and for post-filtration is 243 mg per liter. Percentage removal for this parameter value is 68%. Compared to sewage discharge standard, the acceptable value for COD is 200 standard B. Meanwhile, the initial value of total suspended solid is in the pre-filter water sample is 3200 mg per liter. Reduction of suspended solid occur where the value of total suspended solid of post-filtration is 106.67 mg per liter. It shows that the percentage removal of suspended solid is approximately 96%. The value of total suspended solid was determined in the testing by taking the average weight of 3 suspended solid sample in 50 mg of kitchen wastewater. Acceptable value for total suspended solid based on sewage standard B is 100 mg. And then for the biological oxygen demand, which is BOD, test measure the ability of natural occurring microorganism to digest organic matter in the water. BOD or BOD5 took the average value of dissolved oxygen in 3 wastewater samples. The average value for BOD5 for pre-filtration is 10.32 mg per liter, and then for post-filtration is 5.3 mg per liter. The percentage removal for dissolved oxygen in these two processes is 48.6%. The acceptable value of BOD5 based on the sewage standard B is 50 mg per liter. It shows that the amount of dissolved oxygen decreased after the filtration process because of less decomposition of organic matter by microorganisms. This figure shows the accumulated waste that have been filtered for the past 3 days. The IR sensor detected the presence of accumulated food waste in the filter on the 3rd day. Therefore, it has been established that this food waste filter can accommodate food waste until the IR sensor detects it for 3 days. The result for this process may be vary if the test is conducted on different days according to the frequency of use of the sink or waste products from food waste generated in the kitchen. Next, the step for cleaning or maintenance work start with turn off the power supply of the buzzer and IR sensor, and then discard the accumulated food waste in the first drawer at appropriate place and place the drawer back in the filter. Lastly, turn on back the power supply and use the filter as usual. For conclusion and recommendation, the substances used to filter the kitchen effluent have shown their effectiveness in reducing the rate of impurities in greywater. The highest percentage removal of impurity is at total suspended solid, with 96% of percentage removal from pre-filtration to post-filtration. It shows that the development of this food waste filter using coconut husk, activated carbon and rice straw can help reduce not only solid waste but also the rate of greywater parameters. Furthermore, the use of IR sensor on this filter allows the user in the house to know the length of time required to remove the waste accumulated in the filter. Further study is suggested to collect the data on the rate of use of filter media that allow it to reduce impurities and how long can it last until the next services or change of the filter. Next, I will show you the video of this product development, which is food waste filter that have been installed under the sink.